Okay, we are well into the so-called winter storm that we've all been worrying about lately. And yeah, we're getting a good bit of snow, but I think people try to make more out of it. I'm going to close this door. And then we really should. Because when I was growing up, this was just kind of a normal thing. A couple times a year we'd get a good snow like this, and it would be above the knee, and us kids would have a ball going out there and playing in it with our sleds and making snowmen and having snowball fights and all kinds of things. And now with the advent of the internet and all these things, we've turned it into some terrible tragedy, and I don't know, something we always had, everybody wants to worry about and make a big deal about and look at the internet all day long of, how much more snow we're going to get. I don't know. It's just nature to me. And it's funny that the news tries to make something big of it. It's been 10 years since the last big snow like this. Well, what's 10 years in a world that's 1 billion years old? Anyway, I'm going to enjoy it from the inside of my warm house and make some videos with you. Just thought I'd share this with you all. We'll just see how it all turns out. Hi everybody, welcome back. So in this video we're probably going to continue with off of the last video I did where I showed you some of the basic tools and test equipment you need to get started with a basic electronics bench. And it wasn't a whole lot. It was kind of, I was a little bit surprised by a couple of the comments because a couple folks came on and said that I have way too much stuff, that I had way too many tools, and I just question, did you even watch the video and did you even listen to one word that I said? You have to understand, my bench there's a lot of things that I do beyond just fixing amplifiers on YouTube videos, okay? It's a fun hobby that I do that, but I actually have a real job that I do for a living, and it doesn't involve audio. As a matter of fact, right now, if you look at the bench, I'm just finishing up a couple of things from work that I was working on for another company, and I do a lot of different things on this bench. I work with a lot of different equipment, so some of the things you see aren't necessarily for YouTube videos. And some of the other things I purchased just because I like working with these things, and I take things a little bit further than just repairs. So let's kind of clarify all of this. If you want to be just an audio repair person who wants to actually do this for profit, you're going to have a very different attitude towards this than somebody who's only doing this as a hobby or as a learning experience or something like that. When you repair audio equipment for a living, first of all, today, that's very, very difficult to do. Second of all, you don't have the time to play around and do a lot of the things that you see me do in videos because you really don't care, what the exact percent THD is on an amplifier. You care that it's putting out a clean sound and that it's working as it was supposed to work, as it's intended to work. Usually people send things to you. You're going to locate the defective component, replace it, test it and make sure that it's reliable and working, and you're going to get it off your bench and get the next thing on there, because that's how you make money. You don't make money screwing around setting up all these different test scenarios and learning and experimenting. And hey, what if I try this versus that? No one's going to do that if you're doing this for a living. Things about you need to move things away from your bench so you can get up and walk and all that. Again, if you're sitting 8 hours a day doing repairs for a living, yeah, you have to get up and move around. I'm down here a couple hours playing around in the evenings. That's very, very different. So go back and listen to my first video, what I'm talking about. I'm talking about someone who's watching this channel who just wants to learn a few things and wants to set up a little bench to get started in electronics because it's fun and because they want to do it as a hobby. All right. So just wanted to clarify that, and I mean no harm or no disrespect to anybody, but I think I was misunderstood a little bit, so I wanted to clarify that. So let me get this desk cleared off, and we'll talk about setting up now an audio electronics bench, not just a basic electronics bench. Okay, so in the last video, I mentioned some test equipment. I really only named two big things. One would be a multimeter, and the other would be an oscilloscope. And really, those are the two things for electronics that you need them, especially a multimeter, more so than the scope. Now, to work on audio, you really do need an oscilloscope because you need to be able to look at the waveforms and look at some of the signals in the audio gear that you'll be working on. So you might want to, if you're not familiar with an oscilloscope, you may want to watch some videos or read up on the basics of how an oscilloscope works. I did a series on them a while back myself, and many other people have done probably much better versions of scope theory than me, but learn how to use one. They're pretty handy. Now, the third piece I would buy if I were going to work on audio equipment as far as test gear is concerned would be a function generator. Now this one is specifically called an audio generator because it generates signals in the audio spectrum. Okay, as a matter of fact, it'll go from about 10 hertz up to 1 megahertz. So really that's way beyond. But really what this thing is designed to do is just to make, it can only do a sine wave and a square wave. And you can see how old this thing is. It has been with me from houses to apartments to all over the place. I've had it for many years. And this is just one example of a signal generator. Now this is kind of an older one. Modern ones you can buy on eBay or whatever, your typical Chinese whatever. You can get little ones like this, and you can see it's just got offset and amplitude. This one actually has some damage. I need to repair it, but it does the same thing. It outputs audio level, and you can change the frequency and so forth. You can make a sine or square or triangle. You can make actually different waveforms with this. You can buy, there are many different versions of this type of signal generator that you can buy on eBay or Amazon or AliExpress, wherever. And you really need that in order to make some kind of a signal that you can pass into whatever it is you're working on. You can always use, your phone with the, with the headphone output, or use an audio player, use a CD player or a tape deck or something to generate a sound. But these are more specific because you can actually dial in the frequency, you can dial in the amplitude, you can change the attenuation of the signal, and you get a little more accurate signal. Because sometimes you want to see what is the amplitude of the signal that I'm feeding in, and what is the amplitude that's coming out of whatever it is I'm feeding it through. And when you know what you have to begin with, it's a lot easier to know, what you should be measuring. So I'll give you an example of what it looks like on an oscilloscope. We'll plug it in, hold on. Okay, looking at the audio generator, I have it connected just with a simple cable. It's going directly into the oscilloscope. I'm set at 10, and if you look at the frequency multiplier buttons, I'm on the times 100, so 10 times 100 is 1,000. So that means it's a 1,000 hertz or 1 kilohertz signal, and I have it set to sine wave. And when I turn the amplitude knob, you can see that's called a sine wave. And this is the basic signal that you're going to use when you're testing amplifiers and things. A lot of the tests that you'll do, especially when you're doing alignments, will involve a 1 kilohertz sine wave. And this is how you do it. This is the simplest way to do it. You can buy these used. HP actually makes some old ones way back from in the day. And if you can get your hands on one that's in good working order, they're actually fantastic for how old they are, and a lot of times you can pick them up very inexpensively. If I go to square wave, you can see it's a square wave. That's what it looks like. The rise time is so fast that you don't really see the line going up unless I get really bright, and you almost can see it, but not quite. But that would be a square wave. And you can see if I go up in frequency, the signals get smaller. If I turn back to a sine wave, and if I go down in frequency, the waveform gets wider. See? Just like that. So that's basically what we're doing. And then the amplitude makes the signal louder or softer. See that? And that's really all that it does. Now, if you have a little bit of extra money to spend, you can buy what's called a waveform generator or a arbitrary function generator. And these are a lot more powerful, what they can do. They can also do a sine and square wave the same way. This one has 2 channels, so it can generate two signals at the same time. For instance, if it's stereo, you can generate a right and a left signal, and you can make them actually be different. Let me turn this light off here. And it can do all kinds of things. There are many different waveforms. You can see sine, square, ramp, pulse, noise, arbitrary waveform, harmonics. There's all kinds of things. You can do a sweep. So there's many more types of signals you can generate with one of these, but they are obviously more money. Now you can buy low cost ones of these, Chinese ones, on eBay and whatever, and they work pretty well also, and they can generate basically the same signals as this. The only thing you're going to deal with those is some of those don't have as much electrical safety to them or electrical shielding. If you're trying to look at a very low distortion signal, their distortion is a lot higher than this just because of the way they generate the waveforms. So that's a trade-off. The more you pay, you know, the higher end signal generator. This is a pretty decent signal generator for what it is, but they make other ones that look just like this and output the same signals as this. They're just going to have a little more distortion, and they may not be built quite to the standards as a name brand like Rigel or Tektronix or Siglent or GW Instech, you know, Keysight. You know, there's all different names that are more well known. Some are higher end even than others, but again, you can really get into big money. You can get into many thousands of dollars with these, especially this one's 160 megahertz, whereas I told you the other one that we looked at down there was 1 megahertz. So depending on what you're going to work on is going to depend on which one of these you're going to buy. Now in the previous video, I talked about a dim bulb tester, you know, current limiting bulb, and I showed you what that looks like. And I also talked about a isolation transformer. And again, those are very important when working with any kind of electronics. You may also hear something about a thing called a variac. Let me see if I can grab one here real quick. So this is a variac, and really what it does is you plug it into the wall and you have this big, it's basically a transformer with like a wiper on it that you can adjust and get any voltage from 0 to a little bit above your incoming line. So basically if you put 120 volts in, you can get 140 volts out if you're all the way up at 100%. And what this allows you to do is you can apply voltage very gradually to something while you're powering it up. I don't use these very much at all. Some people swear by them, but this does not really limit the current as per se. Yes, you can say that if you have lower voltage, you'll have lower current. But if something shorts out, a dead short on 10 volts is pretty much as bad, going to be just as bad as a dead short on 100 volts. It's still going to damage things. It's going to be a lot of current. And that's why I use the current limiting light bulb. But there are certain times where you'll use this, but they're a lot of money, and you don't really need to run out and buy one of these, in my opinion. And I'm sure I'll get some pushback on that. But for me, this is something that maybe down the road you might want to purchase. But I know if I don't mention it, a lot of people will ask about it because you see this so often on videos. But it's just my personal opinion. This isn't something you need right away to get into audio work. Now, something you're absolutely going to need is some sort of an audio dummy load, we call it. And this takes the place of your speakers. If you're testing an amplifier and you're testing its maximum power output, or you're testing it in a way that you never know if you're going to have a sudden loud output to the amp, to the speakers, you really don't want to put speakers on that. First of all, it'll blow your eardrums out. It'll get so loud. Second of all, you could damage the speakers. But a resistive load like this can handle that, so you don't have to listen to it. But you can also put your scope across here or your meter, and you can actually monitor the output across an actual load. So this will act like your speakers. Now, yes, some of you audio people out there already know a speaker puts an impedance on your amplifier. This puts just a DC resistance. And there is differences. When we do most of our amplifier testing, you don't want an active load. You don't want a reactive load on there, like capacitive or inductive load. You want a DC resistance so that you can monitor with a fixed load what the amplifier is doing. Now, these are just very inexpensive power resistors. They're called chassis mount metal resistors. These particular ones are non-inductive. What does that mean? A lot of these resistors will have a coil of nichrome wire or something in them to make the resistance. The problem is when you wind that into a coil, that coil technically can act like an inductor. Usually the inductance is so low and audio frequencies are very low, it doesn't affect it, but it can. So resistors that are non-inductive are designed in a way that they won't present any type of a reactive load. It'll be purely DC resistive. Now you can see I have one of each. For an example, I have one that's 8 ohms at 100 watts. I have another one that's 4 ohms at 100 watts. And this is more than enough for most of the audio gear that you'll be working on, is a 100 watt resistor. Now these claim to be 100 watts, but they're only 100 watts if you mount them to some form of a heat sink. You really need something that can carry the heat away from these things. They get very, very hot if you're putting any kind of wattage to them, especially you start getting up 20, 30, 50 watts. These will get so hot you can't touch them. They'll burn your hands. And you have to put a heat sink on them. Now, one idea, and I've made many of these speaker loads over the years, is you can take an old heat sink off of an old CPU, drill and tap some holes in it, and you can actually mount it to where the CPU would have been. And then you have your fan on the front, and you can see I connected 2 wires. Let's back up here so we can see this better. And I connected 2 wires here, one for left channel and right channel. And then I have this little power wire that can plug into my power supply, or you could hook it up to a power supply to 12 volts. And that fan blows air over these fins, and that cools the heatsink and cools the transistors. So this is a really small, fits in the palm of your hand, but it can handle a lot of power because of the fan, because of the heatsink, because of the fins. And you can see I put a little metal aluminum plate on the bottom so you could kind of bolt this down somewhere, on the wall or something around your bench. And it makes a nice little speaker load. Now, and then I also attached these wires where you can actually connect your meter or your scope or something like that. you can take different combinations of resistors and combine them to get different loads. So for instance, you can use an 8 ohm resistor or a 4 ohm resistor, or I could put 2 of these 8 ohm resistors in parallel and get a 4 ohm resistor at 200 watts, or I can take 2 of these 4 ohm resistors and put them in series and make an 8 ohm resistor at 100 watts. See what I'm talking about? So this would be actually probably be 200 watts if at 8 ohms, because I'm splitting it, you know, between 2 resistors. Each one can dissipate 100 watts of heat. So you can do different combinations of resistors to get different types of loads that you want to put on the amp, because you may want to test an amplifier at 4 ohms and at 8 ohms, and sometimes higher or lower than that. Now, another option is you can get into much larger resistors. This is 8 ohm at 300 watts. You see how much bigger it is? And you can see I have it bolted to an aluminum, like a aluminum piece of square stock here. And again, you can hook your amp to this, and this kind of acts like a cooling chimney. This will get hot. The air it'll draw convection air up through here without a fan, and you can put a lot of power in these. Now, these resistors are going to cost more. These can be purchased on eBay or Amazon for a few dollars each, whereas these ones are going to get a little more expensive, but they handle a lot more power. And any kind of aluminum that can, you know, any kind of thing that's got mass to it that can wick away the heat, whether it's made of aluminum or copper or something, it'll cool these. So this is if you want to work on higher powered amplifiers. I'm going to take some pictures of the system that I have, and I'll show you what I use on my bench right now. And I'll just take some pictures. And I did a complete video on this, so you can take a look at it. Right here is the connections for it. If I zoom you in, sorry about all the wires in the way, but this is the left channel, this is the right channel. These are where you connect your amplifier, and then these are where you connect your test equipment. So you can put your oscilloscope, you can go directly out to your scope with this, or you can take this and go up into a distortion meter or some other piece of test gear. You have these little loops that you can hook your voltmeter or something like that onto it, or an oscilloscope probe. You know, you can like hang your probes on there like this and so forth. You can see, and you can very conveniently measure everything. And those resistors that I have are 1200 watts each, and they can handle a lot of power. In other words, there is no amplifier that I'm going to put on this bench that will overheat those resistors or overload them, which is nice, because if you want to do a burn-in test where you want to run an amp at high power for a long period of time, if you're going to work on something like PA amplifiers or something that are always going to be running for long periods of time at high volumes, you want to be able to test them like that, because that's how they're going to be used. You know, you make a repair and it may work at low volumes, but you get it back out into the field and you connect it up to a big set of PA speakers, and all of a sudden something goes wrong. You want it to happen on the bench before you let it go. And those switches on there allow me to get multiple, get a hold of a bunch of different resistances and so forth, whatever kind of load. I can go clear down to like 2 ohms, or I could go up to 16 ohms, whatever I want, just by configuring those switches. And makes it very convenient. But I don't have those big resistors on my bench. They're behind the bench, and therefore they don't take up a lot of space there. Now, the ultimate thing would be a Sencor PA81, and there are different manufacturers that make similar things, but this is a power amplifier analyzer. And inside this are big ceramic resistors that have fan cooling, and they have a thermostat on them to monitor them. It has relays to disconnect the load if it detects a DC offset. It can actually measure the amount of power and read it out to you. There's all kinds of things that you can do with these. And again, this is way overkill, but this is something that you might see in an audio shop where people are working on big amplifiers and things like that. If you notice, I don't use it a whole lot on my bench because it's just not necessary. There's times where it's nice to have, but you can use your resistors and your oscilloscope, and you can do most of what this thing does just with that alone, and you don't need this. But it is a cool thing to have. Okay, from here on out, we're going to be talking about things that are optional. I'm going to show you some gadgets that I use that you may want to use. They're not strictly necessary, but they're good to have. Some of them you can make yourself, like what we're looking at right now. Invariably, there's going to be people that say, you don't need all that stuff. I use my wife's old tweezers for her nose hairs and a set of screwdrivers that I got at a yard sale in 1963. That's all I need. Well, yeah, it's true. You don't need a lot of things. But these are things that could make your job easier and give you a little more options when you're working on these things. So this one right here, this is a speaker overload protect box. Now, as I said on the PA81, if it senses like DC voltage or an offset, like you have a shorted transistor and it's putting the full DC power onto your speaker terminals, this little box will sense that and it will disconnect the speaker load from the from your amplifier, regardless if you have a speaker in there or if you actually have a your dummy load. It'll protect whatever's connected there from your amp or from the short. So you plug this thing in and you can see it has the little light, and after it's on for a little bit, well, let's unplug it again. I'm going to hold this next to my microphone and plug it in. Hear that click? That was the little delay, and then when you hear the click, it's connecting this side to this side. So your amp input goes here, right and left channels, and your dummy load or speaker output goes here. And if something goes wrong, this will cut it off. Now, what's inside there, you might ask? Well, it's pretty simple. I just bought a plastic project case. I bought some banana plugs, a little indicator light, and a power cord you can take from whatever. And I bought one of these. And you can get these on Amazon, eBay, again, the same haunts, They're very inexpensive. This one is self-contained. Some of them require external power. This one does not. It'll just run on 120 volts. So you put your line, your mains and neutral right here. So your mains voltage goes in here. It has its own built-in power supply. These two big heavy relays are what disconnect and connect your speaker load to your amplifier. And then there's just a little integrated circuit on there that's used in a lot of amplifiers, by the way, that monitors things like speaker overload, DC offset. It also will give you a little delay before it turns on, so if the amplifier has a loud thump at the beginning, it'll come on after the amplifier fully powers up. So it's really nice, but these are not expensive. And you can see here, it even has a little website if you want to look at it. And I just mounted that inside this box and connected power to here and here. And these speaker and amps, left and right, go here to here. Now, the only thing you have to remember with these is the negative terminals are tied together. They are common to one another. So if you look, here's the negative terminal for the right channel and negative terminal to the left channel, or I'm sorry, negative terminal to both. See, left and right. And it's all tied together. So if you don't have a common ground amplifier, you do not want to use this. For instance, some of those Carver amplifiers, or some of the big PA amplifiers, or some of the larger amplifiers that can do what's called bridged mode. Bridged amplifiers do not have a common ground. They have isolated grounds from one another. So you got to be really careful with that. Don't want to use that in this case. So the next thing we're going to talk about is something there's really no reason you shouldn't have one, because you can make them. Even the commercially built ones are not expensive, and they're really a good thing to have on the bench. And what I'm talking about is a capacitor discharge unit, or something that can discharge capacitors. We'll go through some of them and then we'll demonstrate them here in a minute. Now the simplest one I just call the stinger cable, and all it really is just a piece of copper rod with a resistor attached to it in here. The other end of the resistor goes to this wire. So essentially, whatever you touch between these two things, like this, it will drain the capacitor into this resistor. And these work really well. And you can use a resistor somewhere around 470 ohms or something like that. And it will discharge a capacitor pretty rapidly. And this is I think this is a 10 watt. I don't even know how many ohms it is. I've been using it for many years and it's always worked. And let's see here. It's a 100 ohm resistor, 100 ohm 10 watt. And believe it or not, a big capacitor will discharge with this pretty quickly, and it won't heat the resistor up. The next thing you could use is still using a power resistor, but you can get a little bit fancy like I did. I have two levels of resistance, a higher and lower to discharge faster on big caps, and a little meter that will show you what the charge is on the capacitor, and there's just a diode circuit in there to make sure the meter always reads in this direction. But it's really just a resistor. The resistor is what's discharging the capacitor the same way as with the stinger cable. The next one would be just a light bulb. You take a light bulb socket and a couple of voltmeter probes, and this does an extremely good job at discharging caps. Now you have to remember, these bulbs here in the States are 120 volts, and overseas would be 200 volts. And I know I always get comments, I can't find incandescent bulbs anymore. Apparently in Europe, it's punishable by death if you get caught with an incandescent light bulb. It's the cardinal sin of Europe. But the truth of the matter is, though, you can still buy incandescent bulbs on eBay and places like that. Another thing that's really, you can actually find them, is traffic signal lights. Many traffic signals out there still have to use an incandescent bulb, and you can see this is a traffic signal light. It even says traffic, 8,000 hour. They're very good, and extra heavy duty filaments. So you can still get these. Just type in traffic signal bulb. They also work really well for current limiting, for the dim bulb testers. So there you go, you can find them. The next ones would be active discharge units. So this is the first one, and these are available on eBay and Amazon and so forth. It's just a capacitor discharger, and you can see it'll go up to 650 volts or 450 depending on the model. And all it does is it uses a MOSFET as a current limiting device, so it will discharge slowly through a resistor, current limited with this. It's a really slick little thing. It even has a tiny LED to let you know that there's voltage there, and I'll demonstrate this. And what I did was I took one of these, because I bought two of them, and I took the little probes off that come with it and attached a set of meter leads and put some heat shrink over it, cut a little hole for the light, and then that way, instead of trying to hold this there, I can hang it by the little hook, and then I can just use these to discharge. It's the same little board as this, though. And then last but not least, I saw this and I couldn't resist. It was cheap. The digital capacitor discharger, and it's up to 1,000 volts. And it works. It's kind of slow, but it works. So let's demonstrate. Now the first thing I'm going to say is I am about to charge this capacitor up to 400 volts. It is a 330 microfarad. And if you got across that, you could really get hurt. So if you're going to do this, make sure you're very careful how you do this. Never come in contact with this. It'll rock your world. I mean, defibrillators that they use to start your heart and so forth use a capacitor like this. So it's no joke. Always use the one-hand rule. If you're going to reach around there, make sure your hand isn't on the chassis and the other hand is touching the live source. You know, put the hand behind your back and use one hand, and use your probe to test. Connect the negative lead with a jumper lead or something like that. So I'm going to charge this up. The other thing I recommend is you can buy these disposable nitrile gloves. You can either get them in 9 or 10 mil, which are very, very thick gloves. And these actually have a pretty high dielectric content to them. So if you're going to be around that stuff and you're a little bit uncomfortable, use a glove. And so what I'm going to do is I'm going to turn on this power supply. This is I believe a 600 volt supply. It can go up to 600 volts. And I'm going to hook this up. And right now it's set to 400 volts at 200 milliamp current limiting. So it'll charge this cap up pretty quick. Let's turn it on. There we go. It's 400 volts. I'm going to put one hand behind my back. And now this cap is charged. Now, just in case you're wondering, if I go over here, you can see there's 370 some volts on there still. So the first thing we'll do is we'll use the stinger cable. And I'm just going to connect this with one hand. And then I'll take this other end and I'll touch it here. And it's just as simple as that. It's discharged. And if we measure it, 1 volt. See that? So that's a real quick and easy way to do it. Let's charge this back up again. And now let's use this one here, which is just a step up from that. And I've done videos on these. And again, and you can see it's discharged. And that's nice because you have a visual indication that it's discharged. Now I'm not going to use the bulb because again, this is a 400 volt cap and I've got a 120 volt bulb. That may not end well. So let's charge this back up again. And we'll use one of these little active dischargers. And let's turn this around so you can see. And there you go. I don't know if you saw that light, but that discharged it. And this does the same thing. It's just, you know, more convenient. It's one of these. And last but not least, I'll show you how this works. It's really important to discharge capacitors before you work on something because you don't want to get that, especially when you're working with vacuum tube amplifiers. Even some of the, you know, like that SX 1980 Pioneer that I'm working on, that thing's got 100 volts at a lot of amps. It will rock your world if you get across that. So you want to be really, really careful. All right, so let's charge it up. Okay, and now we'll use this. Hopefully you'll be able to see the display on it. Let's see how slow this one is. It makes that terrible beeping sound, but it discharges it. So this one's not my favorite, but it is kind of a novelty, and it will work up to 1,000 volts if you trust it. But regardless, you really need a way to discharge capacitors. And again, there's no reason that you shouldn't be able to get something here that will do that. One last thing that I want to mention is if you do decide to go with one of these active discharge modules, they do have a forward voltage drop, meaning they will not fully discharge the capacitor. Case in point, we just used this one, right? And this has been sitting for a while. But you can see I still have 7 volts on there. Now it's 7 volts. It's not going to shock you. But if you touch something metal on there, especially on transistor gear where you have a 20,000 microfarad capacitor and it's only discharged down to 7 volts, you've still got an arc welder there. Whereas if I use the Stinger cable or, one of the resistive discharge units, once I do that, you can see it's really discharged. So these are great for big high voltage caps, but I would not recommend them for like transistor gear and so forth. The other thing is very high capacitance. These things will take a very long time to discharge the capacitor, whereas these resistive ones and even the light bulb, it'll go pretty fast. Okay, so here is another highly recommended piece of test equipment to have if you're going to work on audio gear and things, because being able to test components quickly and efficiently really helps you get things repaired more quickly. It kind of takes away the guesswork. I've done videos on how to test a semiconductor like a transistor or a diode or something, just using a basic multimeter with the ohms, with the diode check selected. You can also use an analog volt-ohm meter to check semiconductors, and there's ways to do that. But these really give you a lot more information about them. Now, I'm going to separate this into 2 different types of component testers. You have the types like this that are more expensive, and they only test semiconductors. And it'll tell you straight up, semiconductor analyzer. The other one, these are very inexpensive, and you can buy them almost anywhere now. They're very popular. You can get them, on eBay, on Amazon, on AliExpress, and all these other places. Sometimes even some of the, Micro Center and places like that sometimes will even carry things like this. But what this is an all-in-one component tester. And you can see it's going to say no component known. But this thing will test resistors, inductors, capacitors, semiconductors. It'll check LEDs. It'll check some of the lower voltage Zener diodes. It'll check infrared emitters. You can buy this thing for like under $30, I think. It's rechargeable, so you don't have to put batteries in it, and it just does a great job. Now these are much more expensive, and they are very good quality semiconductor testers. They're very accurate. They do a good job. The main difference between these 2 models is this one is just a local test unit. So if I put, here's a transistor of some sort. I don't even know what it is. If I put that in there and I just click the button, it doesn't even matter what order I connect the leads. It'll sort it out on its own. And see, it's a silicon NPN transistor. It'll know if it's silicon or germanium. It'll tell you which lead is connected to the emitter, base, and collector. It shows you the forward current gain. Now this is at a very low current, so but you can see this is a really high gain transistor. What is this? A BC549. Yeah, those are high gain. It'll tell you the test current that it used, so it's putting 2.5 milliamps for the for the collector current. It'll tell you your VBE, which is very important. As you start learning transistors, you'll learn the importance of HFE and VBE. And it'll show you the test current for the base. Okay. And it'll even show you the collector leakage current. So it gives you a lot of information about a transistor. Now this one will do exactly the same thing. The only difference is this one has a USB connection to it. And there's a little program you can download for your computer. And if you have a laptop computer or a desktop computer on your workbench, you can connect it to it. And this will do some other things. It'll do some basic curve tracing, which isn't very useful because it can't really apply a high enough voltage or test current. But it can give you an idea of how these small signal transistors work. It can do a little better when you're analyzing field effect transistors like JFETs and MOSFETs and things like that. So it just has some expanded capabilities because of the software program that this can connect to. Other than that, they're the same. There's really no difference in them. This one, however, but that's all they'll do. Semiconductors, diodes, transistors, field effect transistors, things like that. This one, same idea. You hit the button. It tells you the emitter, base, and collector. It shows you the little symbol for an NPN or a PNP transistor. And it gives you all that same information just on one screen. See that? So you don't have to scroll. I really like these. I'm very partial towards, I'm biased towards these. They do such a good job for the cost. And I've had this thing forever, and it just kind of works. But you can do things like you can put an LED in here. Let's see if I got to get this around the right way. I can't remember which pin's which. Nope. Wrong. Let me flip it. Got my anode and cathode backwards. Here we go. You can see it lights up, and then it tells you it thinks it's a Zener diode, because really that's what an LED acts like to this. And it shows you the voltage is 2.1 volts. So it actually lets you know that it's a 2.1 volt LED. And so it'll do things like that. Just a great tester, but this one will go a step further because you can take like a resistor of any kind. Here's a resistor sitting here. I don't even know what it is, but we'll find out, won't we? Connect that, and it tells you it's a 100K resistor. See that? And it is brown, black, black, yellow. Right? It's brown, black, black, yellow. I'm sorry, a 1 meg resistor. Brown, black, black is 100 and then 40. So yeah, 1 meg. 999,000, there you go, 1000K. So it's a 1 meg resistor. You can also put capacitors in here. It'll test capacitors. Even smaller caps, you know, like let's say 100 microfarads. Let's grab one. Here's a 100 microfarad capacitor, and it's an electrolytic. And I gotta scrunch this lead over so it'll fit. And if I hit this, should read about 10 microfarads, and it is, or 100 microfarads, I'm sorry. It's 96.94 microfarads. It shows you the V loss. It even shows you the equivalent series resistance, or the ESR of the capacitor. So it's excellent. You can test so many things with this. It does have its limitations because it's a low power test device, but look how many things you can do with this. So I highly recommend for the money purchasing one of these. These, well, I bought them and I'm not disappointed. They're good, but really they don't do a whole lot more than this thing can do. And again, the software on this is not really something I use much. If I'm going to do curve tracing, I'll show you something that you can do later that is a little bit more affordable, but yet much more useful than one of those. But one of these is great. Now, even though these things do a great job, not only as a semiconductor tester, but also as an LCR meter, or resistance, inductance, and capacitance meter, you can also get a dedicated LCR meter. And there's two different types, basically. There's the handheld ones like this. They also make great big, and I'm not going to move my camera, but I have a big bench HP version. It does the same thing as this. But you can have a handheld one, or you can have these tweezers, which are very, very convenient. The more I use this one, the more I like it. I see where it says 1K there, and if I turn this one on, it's going to have a similar thing. Let's see here. Why is this not turning on? There we go. You can see 1 kilohertz, and you can adjust the test signal frequency. This will go up to 100 kilohertz, and this one here, I can go to 100 kilohertz the same way. And I can go from 100 hertz to 100 kilohertz for my test frequency. That's really important when you're testing certain types of capacitors, and inductors for that matter, because the readings of them will change with frequency. So, like when you're checking a capacitor, like an electrolytic, and you're checking it for ESR, you typically, most ESR meters, like dedicated ones, like this one, which you don't really need because these things do that, they always test at 100 kilohertz. That's kind of like a standard when you're testing electrolytic capacitors. However, when you're looking at things like dissipation factor and different things like that, or loss tangent and things, you might want to check those at different frequencies. So it's nice that you can do that. And again, a lot of the other tests are done depending, like some line frequency things, things that are like linear power supplies. When you're checking a capacitor that's used on a linear supply, you want to check those at your mains voltage ripple, which would be either 100 or 120 hertz. And this will let you do that. Now this is set to check inductors right now, but I can scroll through it and see I can check capacitors, resistors. So if I take this and connect a resistor to it, let's see if I can do this, and my fingers are going to affect it. Let's see if I can get this down here. Here we go. And you can see 993.9K. So it's a 1 meg resistor. Same thing with capacitors. I can go to auto, and I can check this capacitor. And you can see at 1 kilohertz, it measures the cap to be 85 microfarads. But if I go to 120 hertz, this 100 microfarad cap will read about 95 microfarads. And if I go to 100 kilohertz, the capacitor only reads 4 microfarads. See that? And that's why I'm saying having an adjustable frequency is important. It just goes to show how an electrolytic capacitor works versus a film capacitor. So let's grab a film capacitor. This one is 4.7 nanofarads. 4.7 nanofarads. That's what it's supposed to be. This thing is kind of touchy because if you don't get the probes on it solid, it's not going to read accurately. But you could see, if you get it on there good, 4.7 nanofarads. And then back to what I was saying, if I go up to 100 kilohertz, since this is a film cap, it'll still read almost 4.7 nanofarads. So you notice how the electrolytic tested incorrectly at high frequency, but this one doesn't care what frequency you're at. It will always test correctly. That's one of the differences between electrolytics and film capacitors. But you want to be able to test all of them, so it's nice to have a variable frequency. The other thing is the actual voltage. This one lets you change the voltage. You can see I can go clear down to 100 millivolt test voltage, or all the way up to 1 volt of test voltage. And the reason that's important is if you're testing something in circuit, you may have something, there may be a diode or a transistor or something in parallel to the inductor or capacitor that you're testing, and you may be able to, the forward voltage may activate that diode or that semiconductor. If you go below, like down to 0.3 volts, a silicon diode won't break down to about 0.6, so the diode is pretty much out of circuit. But you can still test your capacitor. So you can see, there you go. And if there was a diode across here, you wouldn't see the diode. So that's very cool what this thing can do. This is a really nice piece of test equipment. This one does not have variable voltage, but it does the same thing pretty much. I can connect this, and you can see 4.5 nanofarads at 100 kilohertz. It's the same thing. It has more measurement parameters that you can do, but again, depending on what you're doing, if you're just doing basic testing, for the price, you can't beat this. You can get this like this with the tweezers, and they also make a kit where you can remove the tweezers and plug in a set of Kelvin leads like this. And I'm not going to get into what all that is today, but LCR meters, they're very handy, but again, not super necessary if you have one of these. It just depends on how much you're going to get into this, working on this kind of stuff. But it's important to be able to test small components when you're working on these things, because that's part of the troubleshooting process, and it's also part of the restoration process. You may, an amplifier might work just fine, but some of the capacitors may have high ESR because they're old, and it may not work as well as it could work if you had good components that are reading within spec. So that helps you to know that. If you take a sampling of some of the capacitors in an amplifier, and you get one or two bad ones, chances are they're all eventually going to go bad because those ones are bad. If they're all reading perfectly like new, I probably wouldn't mess around replacing them and doing a recap on the amplifier. So this is another good thing to have. The last kind of substantial piece of test equipment I'm going to talk about in this video anyway, well, there's two more, this is an actual curve tracer. This is a homemade one that the boards and everything you can buy on eBay, I think. And I've done 2 videos on it, got into a lot of detail on it. Other viewers have built one of these themselves and use it. But this allows you to actually measure a transistor over a range of voltages and currents and so forth. Hence the name curve tracers. It'll create a curve for each voltage and current step. And it'll set up these steps, and you hook your oscilloscope to it. And this one actually will let you compare 2 transistors. You can toggle between them. And if you want to match 2 transistors, like some preamps used matched pairs of transistors, and this will help you do that. I have 2 big type curve tracers. One of them you can see pretty easily. It's my 576 Tektronix. This mostly works, although I do have to fix this knob here, a couple little things, but it functions. And then I have another one that's I like because it has an A and B. This one does too. You can go between the 2, and it'll let you match transistors again. This is much more substantial. It can check power transistors, and it can check at high voltages and all kinds of things that the little kit one that I have here can't do. But guess what? I use this way more because it's super easy. I plug it in, I stick a transistor in, I turn it on, and it works. And for small signal transistors, and I'm talking about little tiny things like this that don't use a lot of power or don't dissipate a lot of power in their normal use, this is perfect. It can produce actually a lot more voltage and current than this thing does, and therefore it is a lot more useful when you're doing, because this will do curve tracing if you have the software. Nowhere near as good as this does, in my opinion. Again, I'm sure there's folks that'll argue with that, and that's fine. But just in my experience, what I've been using, I kind of like this better. Now, remember these last few things I've been showing you, I have to repeat myself because a lot of you skip ahead and don't listen and don't watch the whole video. They're optional. You don't have to have this stuff to work on an amplifier. You literally can have, from my first video, the basic test bench thing, and then a dummy load for your speakers and a little signal generator, and you're off to the races, you know. All this other stuff is optional depending on what you're going to do and how far you want to get into it. All right, the next thing I'm going to do, and this is, again, the last big piece of test equipment, is a power supply. And this is one here, this is one here. I have a pair of them here. There are different types of power supplies. This is a programmable one. This one is an all linear power supply, as are these two down here. What is a linear power supply? A linear power supply uses a big power transformer to generate the voltage for the power supply. And there's no high frequency switching, there's no RF noise or anything like that. This one up here is higher voltage. This is good for 120 volts of output. These will only go up to about 35 volts. But the difference is this one is a switching supply, so you have to deal with switching noise that a lot of them will have. Not all of them do. The really expensive high-end ones are pretty well suppressed, and the noise doesn't cause a problem on your bench, but these ones can because they're cheap. But they put out a lot of power. They're very, very lightweight because of no big transformers being in them, and they're really inexpensive. You can buy them on eBay and Amazon and places, and they're not super expensive. If you buy a linear supply like this, they're very clean power, and they don't create any noise, but they're heavy because they have a transformer in them, and they cost a lot more money. So you'll put out a lot more money for one of these than you will for one of these. So it's, again, a choice. Can you get away with a switching supply? Absolutely, 100%. They work in most cases, especially when you're not working with anything that's radio or anything. They work great for the price, and they get you up and running. Just in case you're wondering what this is an electronic circuit breaker that I built as a project. I use this sometimes. It's, again, not necessary, and I doubt that any of you will ever have one because the only way you can get this is to build one. And what this is it's a variac that you can adjust the voltage here, so you can use it as a variac, but it also has a sensor that will sense the amount of current that's being drawn here, and if it exceeds the trip point that you set, it'll cut the power from here. So it acts like a circuit breaker that's electronically resettable. And you can control how many pulses. So, for instance, if your line frequency is 60 hertz, I can count how many half cycles of that 60 hertz have to exceed my trip point before it trips. So if I set it to 1 down here, in 1 half cycle, if you exceed the current that's set by this trip point knob, it'll shut the power off. Whereas if I go up to 8, then it's 4 complete cycles or 8 half cycles. So if you have something that has a little spike in the beginning, it'll kind of ignore that at first. And then if you exceed after that, it'll trip. So it's a pretty powerful test device, especially if you're working on a guitar amplifier or a vacuum tube device. What's nice about this is if a tube starts to go red plate, like something's not, you know, a capacitor is leaky and you're getting crazy bias, or a tube starts to short out. This will trip if the thing starts to red plate before you damage anything in the amplifier, especially like an expensive output tube. You know, you have a bad coupling capacitor and you overload the big output tube. That's a lot of money you just waste if you damage the tube. And this will trip before that'll happen. So that's why I have it. Do I use it a lot? No, but you have seen me use it in certain circumstances. Okay, last but not least is some homemade, I'll call them gizmos, that are very useful for working on audio equipment. And I'll go through each of them and what they do. None of them are necessary, but they're all very handy to have, especially if you want to work on a project, something. These are all homemade. These are all homebrew. I made them myself. I'm not going to get into, I did videos on all of them, so you really don't need, I don't need to go through. But this is a mono to stereo adapter. It doesn't really make stereo, but what it does is it takes the mono output of a signal generator. So I showed you that audio generator at the beginning of the video. You can come out of that, and it's a mono signal, right? And it splits it into two signals that can go out to your stereo amplifier. So you could drive both channels equally. There's nothing in here but a little rotary switch, a dual deck rotary switch. And all it does is you can select resistors anywhere from 100 ohms to 47K, and that just kind of puts a loading, it puts a resistance in between the two channels so that it doesn't directly tie them together. That might be important depending on the type of amplifier you're working on. And it changes the impedance, the input impedance. So basically, depending on if you're working on like some tube devices or transistor or whatever your input impedance is, this allows you to vary it a little bit. I use this thing constantly. When I'm driving a stereo amplifier and I'm doing a distortion test or something, I want to drive both channels with an equal signal. This is what I use to do that. I come out of my signal generator into this, out of this into the right and left channels. So very simple thing, can be built with just some resistors and a switch and some connectors, but very handy. The next thing is, this is a low distortion 1 kilohertz signal generator, and I don't remember, I bought the little circuit board online, and I forget where I got it from, but it was very cheap. It's just the board, and then you had to put your own parts on it and everything. And it uses a plus and minus 15 volts input. So this is your power supply. So positive 15 is the red, negative 15 is the yellow, and then the common is black for ground. And this outputs a very low distortion 1 kilohertz signal. And when I say low distortion, it's like in the, 0.00 something percent distortion. Why is that important? Well, garbage in, garbage out. If you're trying to check the actual distortion of an amplifier, if you feed a distorted signal into it, you're just going to be amplifying that distortion, and it's going to throw off your readings. So you have to start out with a relatively low distortion signal, and that's not as easy to find as you might think. Those cheap function generators that I talked about in the beginning of the video, they don't necessarily have a very low distortion. As a matter of fact, some of them, the sine wave, 1 kilohertz sine wave could have a distortion of like 0.1, 0.05%, which is not really high, at the end of the day, but if it's that high when you feed it into an amplifier, the amplifier is just going to add its own distortion to that distortion, and it's going to skew your results big time. So you may have an amp that's got really low THD, but you don't know it because you're feeding it a signal that's not, real clean. So this is a cheap and dirty way. Now, of course, my DG4182 has very low distortion, so it works really well. But this is a good little thing. All it outputs is a single 1 kilohertz sine wave, and it's very low distortion, and you have to run it through an external attenuator if you want to change, you know, the output level. But it's just very basic. I also have a stereo to mono converter. And why would you want such a thing? Well, if you have a stereo signal coming out of, let's see, a music player or something, and you want to combine both of the channels equally into a mono signal, this is just a little, and again, this is all homebrew. I made it on a little perf board. It's just a little low distortion op amp. I think it might be an NE5532 or something like that. Can't remember what I used. But it basically uses a couple of op amps to combine the two signals, almost like a mixing board does. Think of it as a mini mixing board. And it equally mixes these two channels into one mono signal with a variable output, so I can actually adjust the output level. All right. And that's all it does. And it uses a couple of 9-volt batteries because it actually uses a differential. And yes, I could have done a you know, a virtual ground circuit, but by having the two 9-volt batteries, it lasts a lot longer. And yes, if the batteries are a little bit different voltage, it really doesn't make a difference because the maximum output that's all baked into the design. The battery, one battery would have to be way, way low before you would see any kind of discrepancy in the output. So anyway, and you can turn it on and off, has a little switch. And it works for that. So like if I want to play actual stereo music through a mono device, and we have one coming up that I will be using this on in the future. I'm not going to tell you what it is, but I'm very excited about it. It's a mono amplifier. This will be handy. Last of all is this. It is called a pink noise generator. What is pink noise? What is any kind of noise? You hear white noise, pink noise, Brownian or brown noise. There's all different, they give you a color. But really what it is the color represents, it's just a code that tells you, kind of like the color codes of a resistor. It tells you what energy level it is. So noise in and of itself, okay, when we're talking about noise signal, it is an entire amount of frequencies all overlapping one another. So for instance, a white noise or pink noise generator for audio is going to have every single frequency from like 10 hertz up to, I don't know, 20, 30, 50 kilohertz, all superimposed over it, all mixed together as one sound. So it's a complex waveform of a bunch of sine waves all overlapping one another. And that's called noise. And it sounds almost like a hissing or a wind kind of sound. Now the difference between white noise and pink noise is white noise, each one of those frequencies are going to be equal amplitude. Amplitude, okay? Not volume, but amplitude. So they all have the same energy output at every single, or the same amplitude at every frequency. The problem is our ears don't work that way. Our ears work in a logarithmic way. In other words, you hear certain frequencies more easily than you hear others, okay? So the higher the frequency, the less energy you need to be able to hear that frequency. Whereas at low frequencies, you need more energy to hear it at the same perceived volume by your brain. That's where pink noise comes in. Pink noise has equal energy per octave. What is an octave? Every time you take a frequency and double it, okay, the double of that frequency, that whole range between that and its double will have the same energy. And when you compare it to another octave, all right? And I did a video on this where I actually showed it on a spectrum analyzer, how it looks when you have equal energy per octave. I hope I described that right. I might have totally screwed up that definition, but if you go back and look at the video I did on pink noise generator, it'll show you that. But this is the reason that's important is if you're looking at how an amplifier passes signals, you know what this looks like on a scope. If you feed it into your amplifier and then read it back out of the amplifier, you can tell a lot of information from that because it should come out the same way that it goes in, only just everything amplified. So there's different tests that you can do with a pink noise generator, especially when you're using this in conjunction with, for instance, like a spectrum analyzer or an RTA, real-time analyzer. So anyway, more about that in another video maybe, or just go back to my old videos. But those are a few gizmos that you can use. And when you get to a point where you're doing a lot of this stuff, where you have the means to purchase one, last honorable mention will be a distortion meter. This is a Keithley 2015. Keithley made two different versions of this, the 2015 and the 2016. And the 2016 actually has a couple of extra. It has a wider range of frequencies that it can test and so forth. A little bit better version of this. But this allows you to check total harmonic distortion. Directly reads it out in percentage, and it's auto calibration. So whatever frequency you're feeding into it, it'll identify that as the fundamental frequency, and then it'll calculate the THD and allows you to kind of adjust the test parameters. You could add weighting to it, all kinds of stuff. Expect to pay a lot of money for it, and also expect to have the display eventually will go bad because it uses one of those vacuum fluorescent displays. There are LED upgrades, which I've actually purchased, but I've not put them in because it hasn't been necessary yet. But you can upgrade them to an LED display. But these are expensive, and you don't need it unless you're really going to get into, measuring amplifiers. There are software things you can do if you have a computer, like a laptop computer, that will use your sound card in your laptop, or you can use a audio interface. I don't know if I can show you up here what an audio interface is. That would be right here, this red thing. And the limitation of it is the limitation of its capabilities as far as distortion and noise and things like that. Even these really high-end ones, if you don't get the probes and impedance matching and everything correct, you pick up noise and it'll skew your results. But there are some really powerful software tools you can buy for your computer that'll let you do all kinds of things like frequency analysis and distortion analysis and all this. They also make a dedicated computer-based thing. It's called the Quant Asylum, and those will test distortion and a whole bunch more stuff. Again, it's a big investment. They're a lot of money. You have to learn the software, but they're pretty good. If you're going to use a computer, we also have I don't think you can see it here. It's so tiny. It's just mounted under my bench, but this is made by Dayton Audio, and it's called the DATS, D-A-T-S, and it's another very powerful tester. It can check things like capacitance, resistance, a whole bunch of things it can do, much like an LCR or component tester does, but it's geared towards audio testing. And for the price of one of these, you can buy them on at partsexpress.com. For the price, there's a lot you can do with this thing. It's very, very useful. Again, you need either a laptop or desktop computer and the software, which they give you with it. But again, a really nice test tool. And behind all the wires and things, I have this HP 8903B. This is the old standard. This is again a audio distortion analyzer. It's actually an audio analyzer. It can measure a lot of different things. It'll do synad, it'll do distortion, it'll do signal to noise ratio, a whole bunch of things it can check. Very useful. Usually when you buy them, they're used, they're very old. You sometimes can pick them up for a good price, sometimes they're expensive if you get one in really good condition. Don't be surprised though if it doesn't require an alignment. When I got this one, it did need to have an updated alignment done to it, which I did, and it's pretty accurate. I mean, it'll get way down in the weeds with total harmonic distortion. It has its own built-in low distortion signal generator, so it can generate the signal that it's going to be testing. Very, very useful piece of test equipment. But again, it's big and you can get into a lot of money, and you kind of have to know some electronics to be able to work with this, and also if it needs to be aligned, you have to kind of understand how to do that. But anyway, there it is. So that's it. As long as this video was, there's still a lot of things I didn't cover. And over half of this video, more than half of it, was stuff that, like I said, is optional. You don't have to have these things, but I want to show you what they are and let you know about them so that down the road, if you get to a point in your hobby or whatever you're doing that you want to actually kind of take it to the next level, those are some of the tools and test equipment that'll help you do that. So if you like this video, let me know in the comments if you're interested in one final part where I can actually do a radio test bench. And I'm not going to get real big into amateur radio with transmitters and things like that, because that's another whole kettle of fish. But if you want to learn how to repair tuners, receivers, shortwave, things like that, I can give you some directions on some of the things that'll get you started in that. So until next time, I wish you all peace, joy, happiness, and good health in your lives. And I'm going to go and enjoy the snow now. Take care, everybody. Bye-bye.